Welcome back to the channel. Today we're going to be putting this 420cc Predator engine into this four-wheel drive 2010 Hisun UTV. This off-brand UTV suffered a catastrophic engine failure many years ago, and it's been sitting in a barn most of its life. As a matter of fact, when we gave the battery some juice, we discovered this rig only had 1,100 original miles on it. So basically, this thing's brand new according to my standards. Best of all, we got this four-wheel drive off-brand UTV for practically nothing because these things are kinda worthless. Anyway, we confirmed that the locking rear axle still worked and the push-button four-wheel drive still worked. So, our plan is to repower this buggy with an off-the-shelf engine and retain the four-wheel drive feature. Now, this is the dual-range transmission, and this is the dead original V-twin engine. Normally, the engine's bolted directly to the transmission, and there's no space between these two components. Unfortunately, the shaft that provides power for the front wheels on this buggy passes through the original engine block. That's a big problem that we need to solve, because this shaft will no longer be able to pass through the engine block with the 420cc Predator engine that we plan on using. No worries, we have a plan. And best of all, future Jimbo tells me it'll work. Future Jimbo also told me that the 420 engine is the biggest power plant you can stuff in one of these buggies, and the 670cc Predator V-twin will absolutely not fit. It turns out the 420cc engine is actually a bit too big, but it does fit. Now this engine swap will be done with a few custom-made parts made on a lathe, but overall, we kept this as simple as possible, and everything can be fabricated with an angle grinder, a drill press, and a MIG welder. We kept it simple because we wanted this project to be relatable to folks with common tools, although it does take skill and experience to build the necessary parts. Anyway, let's get started. This engine swap may be sort of hard for some of the folks in the audience to visualize, so to make things easier to see, I'll be using video footage from the future, just to explain how this all fits together. Now keep in mind, this is such a tight fit in the UTV that we didn't have the luxury of wasting 1 millimeter of space. Nope, you see, everything was packaged as tight as we can make it and still have access to all the nuts and bolts. You know, when it comes to engineering, making stuff serviceable is just as important as making it actually work. Ask any real mechanic how they feel about working on most modern cars, and you'll get an earful, including some very harsh language. I build and service my own stuff, so I engineer my stuff to be mechanic friendly. Anyway, as you can see in a future video, this engine's mounted to a platform that raises the engine quite a bit, and that allows space underneath the engine for the drive shaft to power the front wheels on this buggy. Now, pay no attention to this engine. This is the 420cc fuel-injected, stupid-charged, intercooled,
big block
Hemi engine that powered the Honda Insight a few years ago. Here's the engine back in its glory days. Keep in mind, this guy is being fed boost by an AMR 300 supercharger. Very nice. Of course, with the stupid charger, we got the 420cc Honda up to 70 miles per hour. Now that's pretty quick for a lawnmower engine in a car. Ah yes, the stupid things we do for fun. This engine still has some potential, however, for now we're just using it for mock-up purposes. Anyway, if I flip this doohickey on its side, we can now see the bottom. This is how the drive shaft's gonna fit. The drive shaft is going to be using greased bearings to support it, which is a change that you, the viewer, suggested from the previous video. Suggestions are always welcome and I appreciate them, but keep in mind we operate on a tiny double-digit budget, and sometimes the obvious solution is to spend big money, which we ain't doing that. If it can be done cheap, that's the way we're going to do it. Now rolling this on its side again, you can see how much space is ate up by keeping the drive shaft. If we were to eliminate the drive shaft and make this buggy just rear-wheel drive, then we could lower the platform quite a bit, and the 420cc engine would sit a lot lower in the chassis. That's an option that some folks prefer, but I want to prove that the four-wheel drive can be retained when doing an engine swap on one of these off-brand UTVs. Anyway, what you see here is the only way to keep the drive shaft. Now from the previous video, some folks suggested using a jack shaft to offset the drive shaft, and unfortunately that just won't work because something like that would take up way too much space and push the engine too far forward. The setup that you see here puts the engine as far forward as it can go with only an inch to spare. So with the engine mount platform removed, this is the area of the transmission that we have, and we need to fabricate an interface using these 3 mounting locations. I actually spent an hour or so measuring everything and writing it down on a piece of paper. So the secret's out. I measure stuff using the metric system. I know, but in my defense, I really try to keep it American, and whenever possible, I use SAE fasteners. You see, that's the American way. Like it or not, mixing metric with imperial is how we do stuff here. 5/16 by 18 bolts are practically free, whereas the equivalent metric M8 by 1.25 bolts cost real money. In 1975, this country was forced into the metric system, and you could see how that worked out. Give it another 100 years and check back. Anyway, I started off by using an 8" by 8" 1/4" thick A36 steel plate and transferring my metric measurements over. This steel plate is the foundation that we're going to be building from, and this absolutely has to be as perfect as far as the measurements go. Now, I could have used the 1/4" thick 6061 aluminum, but I wanted the option to be able to weld, and I'm only set up to weld steel, not aluminum. So it turns out that welding is not required, and this plate could have been made from 6061. So for something like this, 6061 is ideal. I reckon using a different alloy may be possible, but a softer alloy may not be strong enough. So as they say, measure twice, cut once. At this point, I'm using my calipers to verify my measurements. Now, I could have used the caliper for the whole job, but I didn't. You know, you can do what makes you feel special. I do what I do from experience. A quick visit to the drill press and I can drill out the necessary holes. I started with the pilot holes, and then I went back and blew them out with the correct size drill bit. Okay, just test fitting the plate before moving on. The next step is to drill an 85mm hole right here. This hole will allow the drive shaft bearing support to pass through the steel plate. So I'm using the mill to drill this hole because my drill press will not go slow enough for a hole cutter this big. Now, even with the speed of the drill press reduced as much as it'll go, it's still way too fast. Actually, the mill is too fast and it's on its slowest setting. Once the adapter plate was drilled and test fitted, I went ahead and started welding together the frame to support the engine. The angle iron that I'm using is 3/16 thick. Fast forward an enormous amount of time and I have the parts fabricated for this engine swap. This steel plate was the only part I actually measured and built correctly. Everything else was built to fit, which means no measuring, just kinda eyeballing it. This guy is the platform and the drive shaft bearing support brace. You know, you folks seen all this stuff previously when we time traveled into the future and I showed you how it all fits together. Now we get to see all the individual parts that make up this mounting system. Anyway, this is the actual engine mounting plate. Now, all this stuff was designed to bolt together initially, and the reason is I wanted to have a way to access all the nuts and bolts and other components. At this point, the jury's still out on whether this can all be welded together. For now, we're going to be using nuts and bolts. This is a 1/4" thick 6061 aluminum bracket that holds the original drive shaft bearing collar. This chunk of aluminum sort of mimics the engine block on the original engine. You'll see how all this fits together in a few minutes. Now, these spacers were custom made on the lathe. However, if you were considering attempting a project like this, you could substitute a stack of washers and get pretty much the same result. These guys are the legs for the front motor mounts. Now, these are unfinished and I have to do the final drilling once all this stuff is assembled and placed in the chassis of the UTV. This was a lot of stuff to fabricate in a short amount of time. You know, coffee really helps when you burn the midnight oil. So we do have some problems, but it's not what you think. You see, one of the bearings hasn't showed up yet, and that's going to cause a delay. Now this guy here plugs into the transmission, and it's the interface that allows the drive shaft to pass through the engine block on the original engine. The original bearing required crankcase oil to stay lubricated, but we went ahead and ordered a sealed bearing to replace this. Well, apparently that bearing is coming from Timbuktu, and the estimated time for delivery is going to be real close. So we may or may not have the right bearing in time. Future Jimbo knows, but he's keeping that a secret. Now this front bearing collar thingy also requires crankcase oil for lubrication. So on this side of the drive shaft, we can ditch this crazy looking contraption and use an cheapo bearing. Now the cool thing is, this front part of the drive shaft is 25mm, which translates to 1 inch here in the States. And 1 inch bearings don't have to come from Timbuktu, although they probably do. Anyway, this fits together very nice, and I have no complaints. The red thingies in the bearing are 3D printed spacers to help align the bearings when it's all assembled. Now, the 3D printed parts don't carry any loads, and they're just for alignment purposes only. Let's put all this stuff together and take this project to the next level. So I'm assembling this contraption with random fasteners right now, but in the future I'll be using the correct fasteners with nylock nuts, so no worries. So off camera, I did some gear ratio calculations and I was a little bit disappointed with the numbers I got. Now, this thing has a 3.75 rear axle with 25-inch tires. In low range, we have a 5.1 ratio, and in high range, we have a 3.9 ratio. Well, at 3,600 RPM, this buggy will go 14 miles per hour in low range and 25 miles per hour in high range. That seems kinda slow, but on the other hand, with those ratios, the engine ain't gonna be working hard at all, especially with the CVT drive. Now, if I bump the governor up to 4,500 RPM, I can get this contraption up to 30 miles an hour. That's according to the math. Anyway, if my math is correct, the 420 engine's not going to be stressed at all in this application. Of course, I'm building this thing to be a street-legal go-kart, and with a special permit, this thing can be driven pretty much anywhere in town. Now, going off-road with this thing with hills and whatnot is likely going to be a different story. Well, we ain't got any hills in Kansas, so that's going to be interesting. So here I'm using a pair of 5/16 nuts as spacers in order to mount this drive shaft gizmo. Now this guy is supposed to have a bearing in it, and the bearing still hasn't arrived. The main purpose of the bearing at this point is to keep the drive shaft centered so the alignment with the seal doesn't get upset. The U-joint will fit like this once everything is assembled, and that's how you get four-wheel drive to work on one of these things. Well, I guess that's theory. We still need to test all this stuff. The holes to mount the engine are already in place, so we're good to go. On this build, I'm using the original CVT belt, so the distance between these two shafts need to be the same as the original engine, and in this case the distance is 250mm or 9.84 inches. Now the original clutch won't work in this application, and I had to source a replacement clutch. This is a generic Comet 780 series clutch that'll fit the bill, and this guy was only $115 on the Jungle site. The reason I kept the original belt is these can be sourced fairly cheaply, and it'll be interesting to see how this one holds up. The driven pulley fits here. Now, of course, I don't have the spring in it right now, but you get the idea how all this fits together. Hopefully, I got all my measurements correct, and we'll find out soon enough. The stock 420 muffler is just not going to work, and we'll have to build a custom exhaust system. This downpipe was sourced from Amazon, and it puts the exhaust in the right direction. Best of all, this pipe was made in America. Very nice. Fast forward a bit and we have the chassis prepped for the engine transplant. As you can see, I did a lot of measuring and marking stuff, and that was so I could make most of the parts on the bench. Now, according to my calculations, the engine actually won't fit in the space, and we'll have to cut and weld a few things to get the necessary space. My goal is to have a little extra space in order to be able to work on this thing without any issues. I reckon now is a good time to test fit everything. Let's do it. Fast forward a few minutes and I have the transmission bolted in place, and now I have to work out where to drill the holes for the front mounts. This should only take a few minutes. Okay, so it turns out on the right side, the front mount bolted right up to the chassis using the original holes, which worked out great. On the left side, we weren't so lucky and I had to drill new holes about an inch over. No big deal, I don't think anybody's going to notice. Now at this point, I can drop in the engine, or at least try to, and find out exactly where I need to make my cuts. Uh-oh, well, we have a few bits of new scrap metal, so yeah, the engine didn't fit. Well, I knew this was going to be a slight problem, but it's not as bad as it looks. So up front, I had to cut this section out in order to provide clearance for the valve cover. This chunk of square tubing will be the new crossmember and it'll have to be welded in place. The good news is this modification fits under the plastic without any issues, so nobody's going to notice it. Now, in order to get the clutch to fit and to be serviceable, I did have to cut the passenger seat bracing out. Not a big deal because I'll have to raise the seat about an inch anyway. The exhaust downpipe looks like it'll work, and that'll be future Jimbo's problem. Now this brace will have to get welded, and that's fine. The shifter had to be hacked up a little bit in order to clear the valve cover. This worked out okay, and now I have plenty of clearance. However, I will have to weld reinforcements onto the shifter bracket to compensate for the material that was removed. Now, this engine was set up for fuel injection, and we have plenty of clearance for the EFI manifold. Of course, we won't be using this engine, and the one we will be using will have a carburetor initially. Anyway, it looks like there'll be plenty of room for the carburetor, but we'll have to use an aftermarket air filter for sure. Overall, this appears to be a decent fit, all things considered. Now, keep in mind, this buggy was super cheap, practically free, and we're well on our way to getting it back on the road with a working four-wheel drive system. So, a few compromises are in order, given that this thing was pretty much scrap metal last week, and this week it's, well, still scrap metal until we get it running and move it under its own power. Well, just for fun, let's drop the other engine in it and start it up and see if it'll move. Since we don't have the correct bearing yet, I decided to do a temporary fix and I went ahead and 3D printed a cap for the drive shaft. Today, for our road test, there will be no four-wheel drive. I guess I can live with that, and this is just temporary until the correct bearing arrives. Now, just for fun, I dropped in the little 212cc engine to check for fitment. Well, as you would expect, the tiny engine will fit without modifying anything, although it is a bit low on power. The good news is, getting power from these little engines is simple, and down the road we will test this buggy with the smaller engine. However, today we'll be running the 420 big block. Fast forward a little while and we have the normal 420cc engine installed. The drive belt seems about right, and that's good news. Now today we'll be running the engine with the stock fuel tank and the stock muffler just to make things simpler. Both of these items will have to get removed once we finalize the build. I don't have the battery hooked up for the electric starter, and I'm going to have to rewire a few things to get this guy to start from the ignition switch on the dashboard. But that's okay. Let's just start the engine and send it and see what happens. Wow, the engine runs like crap. I reckon it's been about a year or so since the last time it's run, so... future Jimbo just told me the gasoline in the carburetor is stale and this will clear up in a minute or so. Well, that's good to know. Anyway, the transmission was topped off with fresh oil, so hopefully the 3D printed plug will hold back most of the oil. Let's put this thing in gear and see what happens. Well, the good news is the back wheels spin. Now, I must have left the locker engaged the last time I had the battery connected. The rear axle should be in differential mode, but clearly it's not. Let's goose the throttle and see if the CVT system works. Well, that looks like it's working. Very nice. Fast forward a few minutes and the carburetor cleared itself out and now the idle is too high, but it does run a lot better. Anyway, off camera I stuck the transmission in reverse and reverse seems to work fine, which is very unusual for one of our projects. Let's try the brakes. Yep, the brakes work. At least the rear brakes do. Not too shabby. Well, I reckon I need to lower the idle a little bit and then put a seat on this thing and see if it'll move for the first time in many years. Stand by, I'll be right back. Okay, it's going to start raining in a few minutes and we need to have some fun while we can. I put the roll cage back on because, well, I'm still a 12-year-old and I can't be trusted to be safe. Anyway, I lowered the idle as much as I could and it's still too high. If I lower the idle anymore, the engine's going to stall from the compression relief gizmo kicking in. So I'll probably have to pull the compression relief gizmo off the camshaft to get this thing to idle where I want it to. The gas pedal's not hooked up yet, but it will be someday soon. Anyway, today I'll have to work the throttle by hand. It's a bit sketchy, but no worries. Let's see if the engine transplant was successful. Oh, since I don't have the shifter installed yet, the transmission's going to be in high range for today's road test. So the carburetor is still a bit dirty and I can tell the engine's not making full power. That's probably a blessing in disguise. Yeah, this thing is a lot of fun and it rides really nice. And despite the engine not running its best, it'll get out of its own way pretty quick given its size and weight. I think by next week, we'll have put in all the finishing touches on this buggy and it'll be ready for prime time. Anyway, that's about it for today. Perhaps it's time for you to pick up one of these cheapo go-karts and build something fun. We'll see you next time. Until then. Thanks for all your help today. No problem, Jimbo. Glad to help.